Okay, so what we are going to do today, we're gonna finish the plotting the network on a map, and then we're gonna start with the social network, which is point 4. So now we are in point 3 still. Okay, so I go to the same PowerPoint as last time. We did, let's see what we did. We started with ggplot. I explained a little bit the background and all the different components that we have in ggplot. Data, statics, geometry, and coordinates. Coordinates are always there, but usually I only use them or specify them when I'm working with maps. And this is what we see in the R code. Then we did some exercises with it, and then the second part, this is where we got a bit stuck. ggplot has a lot of different ways of plotting networks. I am going to use the simple ggplot package, but there are many others. Okay, so there are a lot of options. It's expanding a lot. So we're gonna go for chunk 2, and then we only have references, so I'm gonna close this one. And I am going to open the full one, but feel free to open the no solution one. I think we have one exercise maybe for this. But so I want to be sure that you can all run, so whenever your computers are awake, just be sure that you can run the libraries, that you have the packages and everything. I checked earlier this morning, so it should be okay. And then run, yeah.
Is this like last time where we should be using some of the stuff in your folder?
If you have problems, yeah. So if you have problems with it, yes, you will need to go to the folder and take the packages that I downloaded through a different path. But usually, if you do the install, if you go to packages and you install it, here from the ecran, you write down here the package, for example, a graph. You install this one, and then you call the library. It should work. The only thing is, like last time we had a problem because what R is doing, what RStudio is doing, it's calling the internet and is downloading these packages from the internet. So because we have restrictions with the internet here at CDPH, we couldn't do that. So we solved some here, but another one I couldn't solve it from here, so I had to download it at home, and that's this one here, MapProj. And now for me it's working fine, but I want you to try. First, if you don't have the package installed, you can install it through this way, use the CRAN one. And if this doesn't work, let me know and I can help. So first install it, then you call the library, as I did here at the beginning. And then what I will do is set your working directory to find the files until I think edges, and this one, the distance that we were working with. Because everything else that we did later, I believe, is just plotting, so we don't need to run those plots right now. Okay, and you go to chunk 2, which is here. So once you install the packages, if you don't have them installed already, you load the libraries, then you set your working directory, and you call your files, both edges and nodes. Is everyone at this step?
My thing is taking forever to load, but it's fine. I'm just gonna.
Okay.
So Esther, should we? Because normally I always copy it onto my own file. Should I go ahead and do that?
Yeah, you should do that, but I think that you probably have it already, because right now we are using the file, the workshop number 3, which is the one we did last Wednesday, but because of the package problem, we couldn't finish it. So now I'm just gonna finish that one. So you probably have it downloaded already if you downloaded it on Wednesday. If not, feel free to copy paste everything again. Yeah, Monish.
I'm getting like a message here to update loaded packages. Should I say no or?
Yeah, say yes.
Say yes?
Yeah.
Because it's gonna restart our.
Yeah, it's okay.
Okay.
Hopefully it won't take too long. Usually it's a good idea to have the newest packages, the newest versions. It is true that once you upload a version, maybe they have changed something and that can make your code crash. Okay, but then we will find out which is the piece of code that they change, if they change something.
Okay.
But usually it's a good practice, because if you are using an obsolete version, then when you keep writing your code, you're trying something and it doesn't work. You don't know why. And then when you start Googling online, it could be a bug that they fix, exactly. So I always try to work on the latest version, and then be aware that there are different versions. So when you are looking for information of an error that you have, or a warning sign or something like that on Google, if they are asking the question in the proper way, they will explain which version they have of the package, which version they have of the R software. Sometimes they don't, but that helps a lot, because then you are like, okay, mine is like way older, or way newer. So maybe my question is not, this is why this, I don't know, whatever trick they did to solve that problem is not working with you, because you have a different version. Yeah. Usually the R community is very active, so that's really nice. So, I mean, I never had to post my own question, really, because my questions are always there. But I posted some in internal groups in R, but never in the big realm of R. The community is very active, but they're not always very nice. They are very dry and answering. If you don't write a proper reproducible example, they get really upset.
Yeah.
So yeah, so I always post
I've seen that
them
with SAS too, like
with SAS as
please
well.
write-
Yeah.
Be specific or something.
Yeah, which, I mean, it's fair, because
Yeah.
otherwise you cannot understand what they're trying to do.
Yeah.
But at the same time, a lot of people are learning, so they don't even know. But I mean, usually they train them, like, you need to write a reproducible example, and this is a link where you can look for info about it. But yeah. Okay. Should I go, or I wait a little bit?
Go ahead.
I'll go ahead. Okay.
Okay.
So we are in chunk 2, okay? Remember, you can find it clicking here. This is like a summary of where we are. Go to chunk 2, and we are going to plot the network on a real map. So you are going to have a shape file in a folder that is called like this in your computer. And what we are doing here is we are reading that shape file, and we're giving it to this Thailand object. And right now, if I look at the class of Thailand, we see this, it's a spatial polygon data frame. Okay, this is a type of data that we haven't seen because it's more advanced. But anyway, it's a spatial data object. And what I'm going to do to work with ggplot likes things a little bit more simpler, let's say. So I'm going to use this 45 function. And what that is doing, it's converting this spatial polygon into a data frame. So if I now ask, what is the class of Thailand 2? It is a data frame. Okay, and as such, you can look at the first 6 rows with the function head. Okay, longitude, latitude, and these are other parameters that they're giving you. Okay, that this shape file that I downloaded contain inside. Okay, so these things might change depending on where you got your shape file, but you should always have longitude and latitude if it's a spatial polygon. So what I'm going to do, I'm creating a base map. So I call it base map. I could have called it however. This is my object. What I do, I call a ggplot object. So if I run only this, I don't get anything. Okay. So I need to keep adding layers. And remember, for ggplot, when we are adding layers, we add the plus sign. Then I go to the next line and I say add a geom polygon. And now I have this that we already know, the data. Okay, that's our data frame. The aesthetics, the x and y, okay, x-axis and y, which are going to be longitude and latitude. And the group, in this case, this group represents the different, let's say, counties of Thailand, okay? If you have a shapefile from California, these will be like the different counties of the state. I say color gray, so that means that the lines of this polygon are going to be painted as gray. and fill whatever is inside those polygons. I want it to be white. And then I'm going to give these specific coordinates. Okay? Coordinate map. You can just look for this in Google. There are a lot of different coordinates that you can work with, like spatial data can be represented in many different ways. So for example, quick reference, coordinates ggplot2. And you have some examples here. Okay? You can choose many different ones, and it explains, well, maybe not completely, because these two don't have an explanation, but usually if you Google it, you will find an explanation of what each of them are. Okay? And in the reference that I gave you in the PowerPoint, one of the references that is there, you can also get a lot of information on how to plot how to plot the same map with different coordinates. So if I run all this, okay, nothing happens because I just created an object. Okay, I haven't called it, I just created it. Now, if I call my object, I'm going to see it here. As you notice, it does take a while. I told you at the beginning that we can use ggplot, and it actually is taking a long while. There it is. You can use ggplot to plot these things, but it takes longer, or you can use other techniques that will take shorter. And when we are talking about networks at the end of this class and the class on Wednesday, we will not be using ggplot, so it will be way faster. I noticed this morning when I ran this code in this computer, it's way slower than my computer in the office and my personal computer. So what I'm gonna do, I'm gonna be running this, and while it loads, I'm gonna explain what I'm doing, what I did in the code, okay? But anyway, you saw that this is the base map, okay? We have latitude, longitude, this is Thailand, okay? And this is one of the ways of projecting this map here. Now, I want to add the nodes. I'm running that, and I'm gonna explain what I did. We have the base map, okay? That white map that I just saw. And then I'm going to add the points. The points are going to be the nodes, the village, the farms that we have in this case, but in your case could be the different facilities we are talking about. So for the data, I want my data set nodes. If you remember, you just loaded it, okay? So if I look at head nodes, just to refresh your memory, is the data set that we've been working with for the last few days. Aesthetics the same, and color, I'm saying, okay, give the different colors of the different levels of this scale variable. So if you see here, we see nodes, and you have scale. There are market, industrial, backyard. If you have many others and you don't remember, we can do this summary, nodes scale, and it will tell you the different levels of that variable, okay? You can see that scale, it's a factor within the data frame nodes, okay? If you're not sure about that, you can do structure, and it will say it is a factor. If it is not a factor, you will have to convert it into a factor. For example, if you have a character vector, you will have to convert it into a factor with either factor, and then you write here node scale. Oh, well, you will have to do something like this, okay? Or you do as dot factor. I'm not pretty sure what the difference of both two are. I actually usually use this one because in my mind it makes sense, because I want you to read it as a factor. But I know that sometimes this one also works. I don't really know the difference. I haven't checked. So Sam, did you have a question?
Yeah, so where'd you get nodes?
I also couldn't get.
Yeah, nodes, we got it at the beginning. So what you can do, you can go to the magnifying glass here,
Yeah.
and write nodes, okay? What I usually do, I go to the beginning of the document and I say next. Okay, so here in line 20, you have this
Yeah.
exercise.
What's nodes base?
Nodes data final CSV. Is that what it is?
Yeah.
So you just changed to nodes instead of nodes base?
Yes, but node base was from workshops, I think 1 and 2. if you open the R document that we had in like 3.map, I don't think we ever had nodes base here.
Oh, that's the one I'm not open. Oh, I have.
Get CSV.
Ah, okay, because I say load the files into an object called nodes base. Okay, so yeah, so this was probably from last time. So you can either call it nodes. So if you have nodes base, you can do nodes,
Yeah.
nodes base. Okay, that will be the quickest thing right now.
Okay.
Yeah. Sam, is that your problem
Yeah,
or?
no, I just did read.
Okay.
CSV nodes underscore final underscore
Okay.
underscore data final.
Okay, perfect. So we need to have,
That's my,
if you go to environment, you're gonna need to have nodes and edges, okay? And those are coming from nodes data final CSV and edges data final CSV. I mean, it's good that you realize what the problem was. Probably it was telling you something like, I don't know what nodes
Yeah,
is.
same
yeah,
doesn't
and I
exist.
realized
Yeah.
I didn't have nodes.
And I kept
Yeah.
looking, I was like, I don't have nodes.
I mean
nodes.
edges too.
Okay, yeah, because I told you to call it nodes based. Sorry for that. Good. So if we look at here, this is the map that we plotted. It takes a long time to load, but I think it's this computer. I don't know how yours is. Usually, yeah, that's it. Usually it's a bit quicker, but so I have different colors for the different scales of my nodes. So I have 1, 2, 3, 4 types, and I have 4 colors. Okay, I said don't give me the legend. Okay, if I remove this and I run it, which I'm not gonna do it just because it takes a lot of time, you will see that we get a legend here. We're gonna do it here really, so I'm gonna run this one. So what I'm doing here is exactly the same as what I had before, so base map, and then add the geom point, which is the nodes, but this time I didn't say don't give me the legend. Now I want the legend. And then I'm saying to that legend give the name. Okay, maybe I should, okay, let me run this. You're gonna say it better. It just takes a little bit. If I just run this with either this as true or without it, just like this, is the same thing because true is the default. We're gonna get, you're gonna see it now, we're gonna get the name of the legend is whatever you told the colors to be. But if you're gonna publish this or present it to your boss, you don't wanna have this thing here. You wanna give it a name. So to give it a name, you use this one here, scale color discrete, and then you say, I want you to give me the name, whatever. So if I run this now, we're gonna have a nice name for the label of the nodes. Because we divided them according to color, I'm gonna have the names of each of my scale types and colors here. Okay, so this is the market, this is the slaughterhouse, greens are industrial farms, and backyard are the blue ones. So you can imagine this, you can do acute care hospitals, skilled nurse facilities, anything you want. Okay, another one, add the edges. Okay, one little note here, you need to put the edges, we're gonna add them with geom segment because an edge is a link, it's just like a bar, just like, not a bar, a line. We need to add them before because if we add the geom point first, and you can try on your computer, you're gonna have the edges overlapping the nodes, because remember ggplot works in layers, very similar to tidyverse. I'm first plotting my map, and then I'm plotting the edges, and then I'm plotting the nodes, and then I'm calling the name of the.
So pretty.
It's nice, no? Actually, let me run it because it's gonna take a while. Not used to it. So here, what you can see a little difference with geom segment. When you have a line, you need to specify a coordinate for the beginning of the line and a coordinate for the end of the line, because a line is just like a thing that unites 2 points, okay, brings them together. So we have x is gonna be longitude origin, and then we have x end, which is the longitude of the destination. y is the latitude of origin, and y end is the latitude of the destination. Okay, because it's going from the origin node, this is one dot, to this other dot, to the destination node. Okay, I want them to be gray. You can maybe want them red, or maybe if you're going from a backyard farm to an industrial farm, you want that edge being purple. So you can modify all these things. Okay, these are just some examples. As you see here, I'm not going to make it larger because it takes a while, but you see that we have the nodes and we have all the edges, all the connections there. Now, I'm going to add a weight for the edges. Do you know what a weight means in this sense? I haven't explained it yet. The thickness, exactly. So the thickness of these edges, right now here, maybe you cannot see it very well, but they're supposed to be pretty similar. Maybe they are thicker because you have a lot of them overlapping, but not really. It's just because they're very close. The way of putting a weight, you decide which weight you are going to put. So I'm deciding, because we are transferring pigs from one farm to another, or to the slaughterhouse, or to the market, I decided that the size of my edges, okay, the width of my edges, is going to be based on the number of pigs that are being transferred, okay? In our specific scenario here, you are working with people, so we can do the number of people transfer from one hospital to the other, okay? In this case, if you run it without this 200, what I'm doing here, I'm dividing this number, which, let's see, oops, sorry, error, good, because that's not what I wanted to do. If we look at a histogram of the number of pigs that I send, there's a lot of times I have, like, most of the times I have less than 100, and very few I have this number. So if I don't run this 200, and I just leave it like this, you're gonna see that, yeah, it's not a good map. You're gonna see it right now. So what I decide to downscale it a little bit, just for purpose of visualization. Okay, so what I did, you see, you get something like this, and it's like, wow, what is this? Like, this is all wrong. No, it's not all wrong. Don't worry. It's just like the edges are huge. Some of them are huge. So if you divide by 200 or whatever you want, I was doing like trial and
error.
Thank you. Fail and failure. Like, no. Trial and error. And then I say, okay, 200 gives me a plot that I like. You can see that there are a lot. I mean, in your computer you might see it better, but I mean, we can always do zoom. But I'm a bit afraid that this will take a while. You can see that these are thinner. You see, these ones here are thicker because they are transferring a lot of animals in there. Okay. Now, I want to change the size of the nodes according to its in degree. What is in degree? This is a network terminology that I have not explained yet. More or less. What do you think about when you hear about in degree?
The number of, I don't know, individuals are coming?
Almost. But instead, in our case, instead of individual, because it will be the number of transfers, yeah, that are coming. That's in degree. Out degree will be the number of transfers that you are sending. So right now we are not talking about the number of pigs. We are talking about the number of shipments. Exactly. Okay. So in degree is a network terminology. So we need a network. So far we haven't done a network yet. We have this pretty map here, but we haven't even created a network. We've just been plotting like dots and lines on top of a map. We're going to create a network now. And at the end of this class, I'm going to explain in class number 4 or 4 workshop. I'm going to create a little bit more in detail how we are doing it. But basically, I'm using this function here, graph from data frame. This is from iGraph package. And for this function, you need to have d equal edges, okay, and vertices equal your nodes data frame. So vertices and nodes are equivalent, they are synonyms. And here what you put is the name of your edges data frame. Maybe you are calling your edges data frame transfers. So then you put transfers here. And here you put the name of your nodes data frame. And now I'm saying directed true. Why am I saying directed true? Do you know what a directed network is?
It's not just a line, but an arrow one direction.
Exactly. It's not,
Out.
yeah, it's not just a line indicating that there is a connection between two farms. It's actually indicating the directionality of that connection. A and B can be connected, but if you only have a line and you don't have an arrow, you don't know if A is sending to B or if B is sending to A. It could be that A is sending to B and also B is sending to A. But if you don't have those head arrows, you don't know. So here in the network that I have, it's a directed network. So I want to specify that. So I say directed, yes, true. So I run this and I created a network. If I say class net, it's an iGraph class. Okay, this is a network created with iGraph. There are other packages, for example, SNA or networks. Those are different packages. Now we are working with iGraph. We'll go into more detail later. Now we are focusing on plotting these things. So to calculate the degree of a network, we use the function degree, which makes sense. Then you call the name of your network, and then you say V equal the vertices of your network, okay? These are the vertices, which are the nodes. If I only run this, you can see the name of my participants, the name of my nodes, okay? If you have, like with the data that I've been working with the CMS data, here I will have my CMS ID, for example, okay? Then I say mode in. If I write down mode out, it will be giving me the out degree. If I write down in, it's giving me the in degree. And I say loops equals false. What is a loop in a network? I'll help you. I mean,
Go
yeah.
back to
Huh?
telling it to go back to the beginning.
Telling to go back to the beginning, kind of. So it is that, but applied to one of these segments, one of these links, one of these lines. So it's basically that this farm is sending pigs to itself. That is a loop. And maybe within the farm example, it doesn't make much sense. But if you think about the hospitals, you might be sending a person within the same hospital from department A to department B. That will be a loop, okay? So depending on what type of network you're working with, you might want to keep those loops. For me, usually with the networks I work, because I'm working with infectious diseases, I don't care if the farm is moving pigs within different sections of the farm, because I assume if that farm is infected in section A, it's going to be infected in section B, because I'm working with farms at the state level, okay? So for me, usually I remove the loops, but in every network, depending on what you want to do, you might want to keep them or you might want to leave them. For the degree, for the in degree, I don't want to know those loops. So I say loops false. So if I run this line, I created an object that is called in degree. If I run in degree, to give you an idea, this is what I get. I get the name of each participant and its personal in degree value, okay? This is a vector right now, okay? If I say class in degree, it's a numeric vector, okay? Now, I want to put it in my nodes data frame so I can plot it with ggmap. So to do that, I'm creating a new column. This is a column that is called in degree as well. And I'm going to assign this numeric vector of in degree to that new column that I'm creating in nodes. Okay? So if I run that now and I look at nodes, I can see that this last new column, it has just been created. Okay? I just created it with this line. Now, back to what we were doing. Let's map it. I'm going to run it and explain what I'm doing. I start with the base map, and remember what we want to do now. We want to see the size of those nodes depending on their in degree value. This value here. Ooh, look at that. So it looks like, yeah, poor pigs, they are all going to the slaughterhouse. Okay, that's why the size of this slaughterhouse node is huge. Now, I'm gonna make you work.
Should be red.
Should be red, blood red. Yeah, I agree. Totally agree. Should not even be there. Actually, I think later on we are going to remove the slaughterhouse. That's my ideal word. Okay, so I just opened the node solution one. I hope you're there. This is a difficult exercise, okay? It has 3 different sections. It's gonna take a while for you to solve. But I want you to do section by section. First do exercise number 1, then the second, and then the third, okay? So the idea is like, okay, I have this thing here, but I still want to plot it. What do I do? So this is one thing that I would do. I want you to think of other options as well. Maybe, let me think, what would you do? If this is what you have, let's see if it pops out with a little bit of time. Yeah. What do you do with this? What are some ideas that you can think about to get rid of this, or to make it more visually acceptable, or
Weight the in degrees differently.
weight the in degrees different? Okay, that's perfect.
Take out the slaughterhouse.
Take out the slaughterhouse. Yes, I like that. But what if you still want to have it there? Because actually, I mean, we have that slaughterhouse there. If I remove it, okay, as long as I report it, this is the network without the slaughterhouse, is fine. But your boss wants you to leave the slaughterhouse in there.
Can you change the size of this circle?
You can change the size of that specific circle as well. So yeah, so all those ideas are kind of on the same lines, no? Let's make this thing smaller, either by weighting it somehow, like we can weight them all, or we can just make this one smaller. So those are great ideas.
Probably better just to make that one smaller.
Yeah, I think it depends. There are different ways, and you can try different ones and then see what you prefer and decide. Depending on the scenario, it's always like, you need to understand the context. So this is like a fictitious thing. So okay, so I'm giving you here some homework, not homework because you're doing it here, some exercises. First of all, identify which is this huge node. Which one is this huge node? But we already know. Is the slaughterhouse? Is the only purple one. But imagine that you have 3 purple ones. Which one's this one? So that's the first step you need to do. If you want to change this node or you want to remove it, you need to know which node this is. So I'm giving you a tip here, and I'm giving you 2 options. So I'll give you some time. If you are done, give me a green post-it. If you have problems, give me a red one. If you don't give me anything, I will assume you're working on it. Okay, so let's see the first one. We're going to keep going. So identify which one is that huge node. And I give you 2 options. One's the one that I give you the tip, which observation has the highest in degree, and you can use max with which. These are basic functions. I mean, not basic, but from basic R, sorry. Which is going to give you the location, the position of the node that is the maximum of that has the maximum in degree. So for example, if I say only this one, give me the maximum in degree of those, wow, you get one that has 101. Okay, but I still don't know which one. Okay, so if I say which is the position where you can find that one, which row, is like row 18 of nodes data frame. So I can say either I do nodes row 18 and give me all the columns, and you get this one. Or because I don't like working just with these numbers in case something change, I'm gonna plug in just all this thing, I'm gonna plug it in here. And then if something changes, I don't care, I won't even notice. Okay, so I plug that in, but remember I have a comma and then nothing, saying retrieve all the columns. Okay, and I see that it's JSON, and JSON is the slaughterhouse. Okay, makes sense. You can also use dplyr. Okay, this looks nicer, looks more intuitive and kind of easier, I think. You take nodes and then you filter, and you're gonna give me the value where in degree is maximum in degree. So if I run this, I get the same result. Okay, so now please work on the point number 2. I want you to, this is the approach I took. This what Holly said actually. Remove that huge node. I don't want to see it. I don't want to see slaughterhouse there. But then if you remove it, you need to make a note and say, hey, like to your boss or wherever you are reporting, this is without the slaughterhouse. So first, you have to create and work with 2 data frames. First, you're going to create a nodes data frame that is going to have no slaughterhouse. So I'm going to call it like this. Okay, and remove the observation of slaughterhouse. And I give you some tips here. You can do this using dplyr, use pipe and filtering, okay? And then be sure that you remove the maximum value of in degree. And you can use the exclamation point equal operator, which means not equal to. Okay? Once you do that one, I want you to create edges no slaughterhouse, where you're also going to remove the slaughterhouse. And I chose the slaughterhouse because it's a bit easier, because you note that we are working with slaughterhouses, so in this setting the slaughterhouses are only receiving, they are not sending, okay, because the pigs are dead already, so the farms don't want the dead pig. So you will have to focus only on origin type. Okay, so read the instructions and do this too. I might not wait until you all have it just because of time, but I'll give you some time because of the time. So I asked you to create a new nodes data frame and a new edges data frame without slaughterhouse. So it's only these 4 lines really. So we're gonna create this new object. What we are doing, we are taking nodes, and then we're gonna filter, and we're gonna choose the in degree values when we don't have that maximum in degree. Okay. Then the same for edges, but for edges, instead of using the in degree value, we're gonna choose the destination type, because we know that the destination type is the slaughterhouse, and that's what we want to remove. So we can do it like this. Again, there are many different ways of doing it, of doing these things. So maybe you've done something different. It will also be okay. The last exercise is quicker. Okay. Now I want you to just map it, and now use these 2 new tables that we have created. Okay, and you should have the plot mapped without the slaughterhouse. I'm gonna run it so you see what we want, and then once you do that, put a green sticker if you're done, red sticker if you're still working on it. Okay, so the solution is this one here. We do the map, base map, and then we add the edges. And here I'm using for data, I'm using the new edges data set that I have created. And then the rest of it is the same, yeah. This alpha, what this alpha means is the transparency of your edge. So sometimes you don't want it really strong because there are things that are gonna be overlapping. So I like having it a little bit lighter. Then I'm gonna add the nodes, and I'm using the new data set that we have created. And if you see here, the side of the integer, I decided to divide it by 2 this time. Okay, this has been again after trial and error. Then the name of the legend is gonna be this one, and when I run it, this is what I have. So you can see it's what we expect. So you have the market is really big. You have the industrial, big. I mean, it has a high in degree, sorry. And the slaughterhouse that was here is not there. And all the edges that were going to the slaughterhouse are not there anymore. The dot is not there because we removed it from the nodes database, data frame. And the edges are not there because we removed them from the edges data frame. Okay, perfect. So well done. This was a bit tough. Another option, I might go a bit quicker or show you a few, not show you a few things, but you have the code. Another option will be to set a maximum for the in degree. For example, if I want, I say, okay, the maximum in degree is going to be 25. Like I put a threshold. Okay, so I'm going to create a new data frame that is called nodes 25. I'm taking node, and then I'm creating a new column that is called in degree 2. And I'm saying, okay, if the in degree is larger than 25, larger than 25, give me a 25. Otherwise, leave it as the value that we have in degree. Okay, so I create that one, and then I run it, and I change the data frame here. And remember to change it also for the size, for the color, and also the in degree is now in degree 2. It's a new variable I created. Okay, I don't want to override over my original in degree variable. So this is what we would have. We have two nodes that are 25 or higher, and this is how I represent it. This is another way. Other things that you can choose, we can plot only those contacts between backyard farms. For example, here what I did, I created a nodes data frame that only contains backyard, and then I created an edges data frame that only contains edges where backyard farms were the ones that were originating, and this were the origin and the destination. And this is what we have. We have a backyard farm and the connections between them. This, maybe you want to do something with connections between acute care hospitals only. Okay? And this one here, you can see it's a backyard, but it doesn't transfer any pics to the other ones. But it's still there because it's a backyard and I want to see it. Another thing we could do, we can plot only those contacts to the slaughterhouse. This will be like an ego network type of thing, that you only care about one specific hospital or one specific node, and you want to see everyone who's sending to that node. Okay, so what I'm doing, I create a new edges data frame where the destination type is slaughterhouse. So in this edges data frame that I'm creating, if I look at the beginning of it, I see that the destination type is slaughterhouse only. Okay, all the time. You can do many other things to double check, but I won't because of the time. So now, if I do that and I use those nodes, that data frame for the edges, but I leave the data set of nodes here, I'm going to plot all the nodes that I have, but the edges, the connections, are going to be only the ones that go towards the slaughterhouse. Okay, and this is what you have. You can do many other things. This is another thing. If you want to do 2 and 4 from the slaughterhouse, you use this thing here. This is new. This is equivalent as OR, O-R, okay? So which are the positions where we have destination type market or origin type market? So this will be 2 and 4 from market farms, okay? So I create this edges data frame, and then I plug it in here. Okay, do you get the idea? Okay, so that's all for this third workshop. What I'm gonna do, I'm gonna clean my environment. Okay, so I have nothing in here. I think, is it cleaning? Yes, okay. I have nothing there, so I'm starting from scratch, from 0, even though you can see all those things, it doesn't matter. And now what I want you to do, I want you to go to 4. And remember, if you can copy paste it in your own folder so you don't modify this that everyone's sharing, that will be great. I'm gonna open the PowerPoint first, and I'm gonna get more into terminology and network theory, terminology of social networks and network theory. And we are working with iGraph. So just as a reminder, what we need for our network is going to be a node table and an edge table. The edge can be, you can have an origin and a destination that will be directed, or maybe you just want to talk about a relationship between people or farms or hospitals, but you don't want to talk about the directionality. That's okay, but you still have one column, and you have two columns in there. Optional, you can add some node attributes and edge attributes. For example, if you want to plot it on a map, you're going to need node and edges, node attributes actually, which longitude and latitude. And you can add as many attributes as you want. This is a reminder of what we saw last time. There are other ways as well. You can create a network from a matrix, from vectors. They are simulated pre-written functions. But we are going to use one for a matrix, so you see how it is. But because of the nature of our work, we are always going to be working with data frames. So this is what we're going to need. A little bit about terminology. This is a network here. These are the nodes, okay? We saw that last time. And the links, the edges, are these lines that are bringing them together. We talked about directionality. It can be undirected, as this one here, or it can be directed. For example, there is reciprocity here between these two, but this node here sends to this one, and this one doesn't send to this one. That's what these head arrows mean. I'm going to delete them because to explain the rest of the terminology is easier to understand or to visualize it in a small network that is undirected, but it also applies for directed networks. A path and the path length. A path is one step. So from here to here, from this node to this one, we have one step, one connection. From this node to this one here, we can go this way, 1, 2, 3. So the path length can be 3. But we can also go 1, 2, 3, 4. That will be 4. 1, 2, 3, 4. That will also be 4. There are different ways of reaching one node, going from one node to another, okay? Especially here it's undirected, so we can do many things. The shortest path, as the name says, is the smallest number of steps or paths that you can spend to go from node I to node G. For example, this is node I and this is node G. So the shortest one we saw is 1, 2, 3. So the shortest path between this and this node is 3. Okay, that's also called geodesic distance. This has implications for diseases. So why do you think this is important? What happens if we have if the shortest path is really, really big?
Well, we'll have to go through multiple places until it reaches.
Exactly. We'll have to go to multiple places or nodes to actually have everyone infected. So if the shortest path is really small, the disease is going to get spread way faster. It's going to reach everyone way quicker, okay? Because just with 1 or 2 steps, you're already infecting someone, so imagine. But if it takes if the shortest path is 10, okay, the disease is going to spread a bit slower. Of course, it depends on many other things, but network related, like we think about it, this is important because of that. The concept of farness, this is so far away, is the sum of those shortest path lengths, so the length of those shortest paths from node I to all the other nodes of the network, okay? So let's say we have this node I. For this one to reach this one, the shortest path is 1, okay? So put it on the side, that's 1. For this one to reach this one, even though we can do this, I know that the shortest path is 2, 1, 2. For this one to reach this one, we mentioned is 3. Okay, so that's 1, 2, 3. We sum that, that's for this node I, to reach this one here. But then what if this node I wants to reach this one? Then we need to sum it again. So this is a very small example. We can spend a lot of time talking about this. They're really good YouTube videos. I left 2 links at the end of this PowerPoint that explain some of these concepts. That they are really good because they spend a lot of time and they give you a lot of examples, which I don't have that much time here, but yeah, you get an idea. And if you want some reinforcement, there are those videos out there. Centrality. So centrality measures in plural. There are a lot of different types of centrality measures. I'm bringing here 3. I've seen, depending on where I look for the definition, it changes a little bit, so that is confusing. But what I'm giving you here is what I found like more widespread. All these measures, I want to tell you, that can be normalized, and that's very useful when you're trying to compare your network with someone else's network, because otherwise you wouldn't be able to compare them, because the size is different. And okay, so we have the degree centrality, which we talked about a little bit today already. It can be, degree centrality, just like that, will be for an undirected network. For example, this one here has a degree of 3. Well, we don't know if it's in degree or out degree. If we have a directed network, then you can see how many you are receiving, and that will be in degree. How many you are sending, that will be out degree. Then we have betweenness centrality, and this is the proportion of shortest paths from I to J that go through a node that is K. Okay? Proportion of, repeated for all the nodes of the network. So it's a global measure. But it can be, global or not global, depends. But if this is I and this is J, this is K, so proportion of the shortest path from here to here that goes through this node. So in this situation, we know that the shortest path, there's only one, okay, and is this 1, 2, 3. So there's only one shortest path, and in that shortest path we have node K. So that will be a 1 from this node to this other node. What happens if we are talking about these 2 nodes? We have this node here, and let's see which one. I've always forgot because I did this many times. I should have written down. 1, 2, 3, 1, 2, 3, 1, 2. I was thinking of this one and this one here, but this is V, so it doesn't make, I don't know if it makes much sense. But anyway, think that, sorry, I thought about this so many times that anyway, think that we're going from this node to here, and we want to know the betweenness centrality of this one here. So we have 2 different ways of going through a shortest path. It will be, we have 1, 2, or we have 1, 2. Okay, okay, makes sense. So we want to go from I, this is I now, this is J, and let's say that this is K. That's it. So we have, in one of those shortest paths, K is there, but in the other one, K is not there. So this will be 0.5, okay? Because we have 1 that passes through it over 2 possible ones. So that will be 0.1. Again, there's a link that might explain it much better. Then we have closeness centrality. This is the reciprocal of farness, and the reciprocal means 1 over. So farness was the sum of the shortest path lengths from node I to all the other nodes in the network. So if you do 1 over that, you get closeness centrality. Then in this case, if you normalize it, instead of doing the sum of the shortest path lengths, you do the average length, okay? This one we can only calculate it properly if we have a fully connected graph. A fully connected graph will be something like this, but what about that image that I just showed you before when we were talking about the backyard farms? There was one farm down there that was not connected with the other ones, okay? So that is not a fully connected network because there are different groups, different groups of farms or nodes that are not, and they are not all connected, okay? So this is a table that I saw in Danon et al. And this you have access to this article in the library. I added this one here. This one is added by me, but everything else is from him. I think it's a great table. In this graph theory thing, a lot of times we have like 5 different words to talk about the same thing, and it can be very confusing. So something like this is very useful. So let's work a little bit. Let's go to chunk 1. You're going to open no solution 1. Okay, I'm going to open this one right now. And you should already have these 3 libraries and packages and libraries, but load them and be sure that you have them, you can access them. And I'm going to start, well, I'm going to show you what we have here. We have 2 chunks. We're going to finish this on Wednesday. I don't have any other material so far, unless you want me to do something else. But this is what we have for Wednesday. We're going to start today and finish on Wednesday. We're going to go as far as we can today. In the first chunk, we're going to work with an undirected graph, and then we're going to work with a directed graph, okay? Most of the times we're going to be working in real life with directed graphs. I've never worked with undirected because of the nature of my work. But I wanted you to see it so you can understand some measures with that. In this case, well, I'm using this book is delicious. I love it. I love it. You also have access to it, okay? In the PowerPoint presentation here again at the end, you have some references. This is this book here. This one is also really good. Yeah, both of them really are very nice. And these are examples from that book, and you can get, not from the CDPH because you cannot get GitHub, but maybe from home you can get a lot of the documentation from the book there. So here I'm just created a matrix, and as I mentioned before, we can create a network from a matrix. So if I look at this, okay, this is a matrix that I created. 0 is like no contact, and 1 is that they had contact. I'm giving names to the columns, A, B, C, D, J, and games to the rows. So now if I look at it again, we can say A sent to A and B had a connection, C and D had a connection, okay? So that's how you represent a network in a matrix. And then to read it, we use this function graph from adjacency matrix. Before we saw graph from data frame. This is a bit different, but basically is the same. You put the name of your matrix here. Now I'm gonna say this is in the undirected, okay? And I'm saying don't give any weight here because yeah, it's an undirected. I don't want any weight. I want something simple. So I create graph undirected GU. I look at the class, it's an iGraph. I look at the network, and this is what I have. This is a random number. You probably have a different one that, yeah, I never pay attention to because it doesn't mean much. Then I see this is an undirected named, because I named the columns. Well, A, B, C, these are names of people or facilities or farms. And then I have 2 slashes here. We'll see this later, what this means. And I have 10 rows. No, I have 10 nodes and 12 edges. Okay. I have for the attribute so far I only have the name of the vertex, and the edges for this thing, that this is the same number as this. Don't pay a lot of attention to that. For the edges, I have these things. A and B have a connection, A and C, B and C. If you want to use some time, you can double check that is true with this. I'm not going to do that now. To call the nodes of your network, you say capital V, and then you write down the name of the network. And these are the nodes or vertices. These are synonyms, okay? And these are the names of those 10 nodes that I have. If I do this with the other data that we had with the farmers, I will be getting the names of my farmers. If I do the same with E, capital E, I get the edges of my network, okay? Simple visualization. This is way faster than ggplot, okay? I am going to set the seed, and this means that because every time I run this line, it's going to give me a different plot, because the way it shows you the nodes it's random. Okay, if I run it once, I get that. I run it twice, I get something different. I mean, the position of the nodes. The links and everything else are the same, but the position. And because I don't want it to be different, I want you to see it clearly. I don't want any confusion. I'm going to set the seed. This means that if I run it before running this line, it means you're going to do like a specific. So what it's doing a random thing is like taking there are like several lists, and it's taking like a random number of those lists and decided this is how you're going to plot it. If I'm setting the seed, I say choose a specific number of that random list. So every time I run this, doesn't matter how many times I run it, it's going to be running exactly the same plot. So luckily you will have the same plot and we can talk about it together. So what I'm going to do now, that's basic visualization, okay? What I'm going to do now, I'm going to add some node attributes, okay? I'm going to add the variable gender. So I'm going to create gender. It's a factor. Hopefully in real life you don't have to make, I mean, not hopefully, you won't have to make it up. You will have some attributes of your hospitals and you want to add it to your network. If you haven't done it in the nodes data frame, you can add it later on directly in the network, and that's what we're going to do now. I'm creating this factor, this vector factor that is gender. Okay, so if I look at gender, it's a vector of males and females. And what I'm going to do, I'm going to assign that vector of factors to this new column in my vertex. So in this case, it's not really a column, because if you look at vertices again, this is not a data frame. You cannot see a column here. But if I add it, okay, and then I run my network again, you will see that now we have a new attribute that is called gender. And you can see it's a vector attribute, a node attribute, okay? If this attribute, if we would have put it in the edges, we will see an E here. It will be an edge attribute. But it is a vector attribute because I put it in the vector. So now my vectors A, B, C, D till J, they have a gender. I just did it. And what I'm going to do, I'm going to change the color of these bubbles according to gender. So what I'm doing here, I'm creating this vector, which is simply a combination of two colors because I have male and female. So I use these are colors, but you can also put red or green, just like that, okay? I'm using these because they are colorblind friendly. I found them online. But yeah, you can just type red, okay? I'm going to leave it like that. So I created that variable. And now, this color attribute of the node is something that it's a predefined attribute. So this network that we did, the nodes, they have this attribute in there, but right now we haven't seen it because we haven't assigned any value to it. But now I'm going to assign the value. And the way I do it, I put the name of my vector of colors, and then the factor variable, that factor variable that we just added. Okay, I'm putting this one here. If I run only this, I'm still not even talking about with the network right now. If I run that, I get a vector, okay, of colors, and where I had male, let's see, where I had male, I have this color. Where I had female, I have this other color. Okay, so this vector of colors, I'm gonna add it to as a node attribute or vertex attribute to my network. Okay, if I now run the network, I can see that I have a new attribute that is called color, and it's a vertex attribute. Perfect. So now I'm gonna plot it. I set the seed, and I'm gonna plot. You can say plot.igraph or just plot. It doesn't matter. I call my network, and now I'm gonna start like changing it a little bit. I'm gonna say I want the arrow size of the edge to be 0.2 and the vertex color to be this color here. What do you think is gonna happen? I'm gonna get different colors here. according to the gender. Okay. Is there something extra here? There is something extra. Why am I talking about an edge arrow if I don't have any here? I don't have any edge arrow. Why don't I have an edge arrow? Exactly, this is an undirected network. So I can remove it and I will get exactly the same thing. Okay? What if I remove the color part? I will get again the same thing as what we got before. Okay, well, no, sorry. So I get exactly the same thing. Why? I am not saying give me this color, however, it is giving it to me. Why? As I mentioned,
It applied, so you would have to change
it applied to it, yeah. So what I mentioned before is like this color attribute, it's an attribute that actually is there, but at the beginning we didn't see it because we didn't give it any colors. But now that we already gave a color to our network, we can see it here, okay, or we can see it when we run Goo. Now that it's there, I don't even have to specify because it's a predefined attribute that the network was waiting for. Now you gave it to him, you don't need it. You don't need to keep calling it all the time. It's the same with this name. This name attribute, I never created it. It was created automatically with the names that we have in our network, that in this case is A to J. So I'm going to explain this, which you almost know already, and then you have one exercise, and then we leave. Okay? I'm going to start talking about these centrality measures. We already saw with the previous example, with workshop number 3, the degree centrality. In this case, we have an undirected network. So I just need to say degree, write down the network. And now in this case, I want the loops to be there, even though it doesn't matter because I don't have any loops in here. I can remove that, but anyway, I'm going to leave it. If you see this extra parenthesis that I wrote down there, if I run it like that, it's going to call the object at the same time that it's creating it. Okay, so this is saving me a line of code like this. Okay, it's calling it directly. And I'm talking about this extra parenthesis, okay? Because I want to see what happened. It's like, okay, A has a degree of 2, C has a degree of 5, okay? Now I'm going to assign those values to a vector attribute or a node attribute that is going to be degree. Okay? Now if I call Goo, I'm going to see that degree is a vector attribute, as I would expect. Now if I run this and I say give me the vertex size according to the value of the degree, okay, and I'm multiplying times 10 because if you run it, you can run it in your computer, you'll see it gets really small and we don't see anything. And I'm calling this plot degree, okay, and this is what we have. Now we have colors and we have different sizes according to their degree. We can also do a normalized degree, okay, and this normalized is like they're dividing by n-1 when n is the number of nodes, and you can see that looking at degree and looking at normalized, what it means here, okay. So we're gonna do a normalized degree. I'm doing the same thing. I attach it as a node attribute or vertex attribute, and now I plot it and I say, okay, this is a normalized degree. Now yeah, this is the exercise. Okay, so betweenness is very similar. Instead of degree, we call betweenness. I'm going to do the normalized one. Okay, and I call it, and the plot changes. You see now these have higher betweenness, this one has a bit less, and the other ones have almost nothing. So I want you to do this exercise. Okay, I started it for you, but I want you to finalize it, plot it, and I think you have a question. Let me check. Okay, I don't have a question in this one, but just plot it. I created it for you, but I only created the vector. So what you need to do here will be to add this value to your network as a vertex attribute, and then you're gonna have to plot it. And I want you to plot it with this seed of 533. If you change the number of the seed, you will be changing the plot. And if you keep using, like, I don't know, if you set seed at 50, you will have a different one than mine. But if you always keep it to 50, you will always receive like kind of the same. Green stickers if you are done. So remember, we just created an object that has the values of the closeness, centrality for each of the nodes. And now what I want to do, I want to create like a new node attribute or vertex attribute in my network that it's gonna contain these values of closeness, centrality. And then once I have that, I'm gonna plot the network using the seed 533. If you can give your plot a name, like normalized closeness, and then you will decide if you need to multiply that closeness value to visualize it better, or maybe you have to divide it if it's very big. I don't know. If you are struggling and you want help, give me a red sticker. If you are fine done, give me a green one. If you don't give me anything, you're still working on it. Okay, do you want me to go for it? Yes? Okay, so if you look at the screen here, I am creating the vector, that is it has the values of closeness of each of the nodes. I'm gonna assign, I'm gonna give that value to my network, okay? And I'm gonna plot it. To plot it, I say plot the network. You're gonna give me a vertex size of this, and then I decided I'm multiplying it by 50 because it's pretty small. And then I want you to call it normalized closeness. Okay, and this is what we get. So now what I'm doing here, I'm just plotting the three networks that we had, okay? And the way I'm doing that, I'm gonna plot them all in this window. And to do that, I'm changing the parameters of the plotting thing, the characteristics. I'm saying give me 2 rows and 2 columns, and this is the size of the margins, okay? So I'm starting with that, then I'm gonna plot my 3 networks, which we just did, but separately. I want to put them together. And then don't forget to put it back to whatever you want. Otherwise, every time that you plot something, it's gonna have these characteristics. I don't want that. So I'm plotting all of it. I'm calling all of it. And I'm getting this. And after this, I'm gonna finish. But it's just like, I wanted to stop and think. What does this mean? We have the normalized degree. This one, the C, is the most important one. Is the biggest. Is the one that has a higher in degree. Sorry, not in. The higher degree. We have normalized betweenness. If we look at this one, it seems that C and G are the most important ones, followed by H. And the other ones are really not that important. If we look at the normalized closeness, I don't know, these two, okay, still very important, but also, yeah, this definitely more important than those. I think this one's kind of the same as that one. So, just looking at this, how can you tell which node is the most important one? Is there even a most what?
Depends how you define importance,
Yeah.
right?
Exactly.
I mean, C seems like it would be only one focus.
Yeah, C and G look big, but really these are 3 centrality measures. There are many other measures. So it's what you said. It depends on how you define important. So it's going to depend in each of our specific scenarios. And that's when we need to think instead of just running a piece of code. You need to think, what is important in my network? What is important in my specific scenario with hospitals, with people, with animals, with farms? And also, what are you looking at? Because maybe even you have the same data set, but one day you want to look at degree for a specific purpose, but then you have a different question, and for that, the answer of that question is going to be the betweenness, the one who's going to give it to you. So, depending on what you want to do or which question you want to answer, you're going to be using different centrality measures and different parameters. Not parameters, but measures. Yeah. Okay? So we're going to leave it here. Next time we're going to start with a directed graph. We're going to keep working with the nodes and edges data frame. We're going to do a bunch of other things with a directed graph. And that will be the last day. Okay? Okay, thank you.